in chapter 7. Okay, so we're going to start fairly simple and work our way to more complicated. Okay. In your homework, you will see a variety of problems. Okay. However, the ones that I will be concerned about for the test are going to be the last ones we see that involve the calculus. Okay.
Want to try one?
What are they?
I don't know.
Izzy gave
I don't know. Let's eat.
May I try one?
You have a whole box of stuff you're not sharing, Benjo?
Well,
You have pretzels you don't share.
I've been
Okay, here we go. So, the center of mass for a system. Who could describe it to me?
Okay, so I'm pretty sure it's like where like the mass on all around it is like even pretty much. So
Okay, yeah. So it's basically where the mass would be concentrated. Where could we like balance? Okay, if I put this object on a pencil, it would balance at the center of mass, right? Okay, as long as the density is consistent. Okay. Yes.
Where's the center of mass on that picture? At the point or at the?
At the point.
Okay.
Okay.
Wait, so what does constant density mean?
Like, this pencil doesn't have constant density because of the rubber that's attached to it. If I take this rubber off, then the plastic, like, it all has the same density. But the plastic plus the rubber, we have different density.
So that would change the center of mass.
Mhm.
Okay.
Yeah. Okay. Now, each mass in the system has what we call a moment. Okay? Not like I need to take a moment, but
You might after this.
I usually do. I am very thankful lunch comes after 4th hour for me. So the moment is the product of the mass and the directed distance from the origin. Okay, so we take the product of the directed distance and the mass.
Hi, Richard.
Richard.
That's it. Just say hi.
Hi, Nick. I didn't forget about you.
We don't want to spoil the surprise.
I'm sure you already raise your hand if you've texted him or social media. What did he say back?
He didn't say anything. I don't know where he is. He probably died somewhere.
Wow.
What is wrong with you today?
He might be sick.
I think you
Like-
need to just stop talking.
Like, he might be
Every time
That
you
might
open
be
your
for the
mouth,
best.
you say you're
Okay.
kidding, don't you? It's
So we would take 4 times a negative number because it's to the left of the origin, and we take 6 times a positive number because it's to the right of the origin. Now, I don't have those distances measured out in this picture, but that's what we would need to do. And with those, we would actually add the moments together. Okay, for the first moment. And I don't really care about you remembering that it's called the first moment, but we're going to take the sum of all of those moments. And to find the center of mass, we would take the sum of the moments and divide it by the total mass. So we're taking mass times distance plus mass times distance plus mass times distance, and we're dividing it by mass plus mass plus mass. Okay? Now, when we think about that, I mean, that kind of makes sense for a center, right? I mean, it's like we're finding that average. Okay. In the numerator, we have mass times distance, and in the denominator, we have mass. So, as far as like the label, the masses are going to cancel out, and you're going to be left with some sort of a directed distance, right? As far as the fraction is concerned. And that directed distance is our center of mass. Okay, so we are going to start with a linear system, kind of like this picture is. Then we're going to look at, okay, what if we're on more of a grid type system where we have x and y distances, and then we're going to actually talk about like a region, a bounded region, like we've been working with. Okay, it's going to be okay. It's going to be okay. All right, so this is. Do you have it written down? You promise? Okay, so we're good.
Wait,
Okay.
can we go back?
I know. So we have 10 grams to the left, 15 grams in the middle, 5 grams, 4 to the right, and 10 grams, 7 to the right.
Oh, it's 10 log.
10 grams. We have a log. 5. Oh, that's funny. Yes, Chris.
For distance from origins, that like if it's like a square or like a cube or something, would it be the closest part or the part that's furthest away?
It would be the center.
The center of the.
Mhm. Okay, so what we are going to do is we need to find the moments and add them together and divide them by the mass sum. Okay. So first of all, what would be the sum of the mass?
40.
Okay, so that's your denominator.
Yeah.
Okay, and then for our numerator, we're going to take 10 times negative 5. And we're going to add it to 15 times 0 because 15 grams is in the middle. And then we're going to take 5 times 4 and 10 times 7.
So the middle one just goes away. Right.
Well, yeah, because it's times 0. So it's not important. I mean, it is important, but since it's in the middle. Okay. So our center of mass would be 1 unit to the right of the center. We could balance this object, this number line, this weighted number line is what I'll call it, on a pencil at x equals 1.
Isn't this like relative though to like the origin?
Yes, relative to the origin, yes.
What if you don't have an origin and you're just within the center of mass of like this pencil?
Then you determine a origin.
Oh, okay.
You create, because no matter where you put your origin, since we have directed distances, it'll still get you the same spot no matter where your origin is. Your x will be different, but it'll still be the same spot on your pencil. Did that answer your question? Okay.
Okay, could you technically do this, but instead of doing the center of mass, you just did it like off to the left or off to the right, while still being on the mass? But you did that for like, because like if you changed it for everything, would it really Like, would it screw up the whole equation so you didn't get the right answer? Like, words are coming out of my mouth, but I don't know if you're understanding what I'm
Well,
saying.
I'm not. If we change the problem, is that what you're asking?
Well, what I'm saying is, like, we do it from the, like, if we have, like, a random object, we, this equation operates, like, from the center of mass, and that's what we use for everything. But what if we do it, like, to the left of that?
Well, we put it at the origin. So, like, 15 grams is, like, our origin, basically.
Well, I mean, this says, like, 5 units left to center, and then in the middle, 4 units right to center.
Yeah.
So if I just, like, moved it so instead of using the center, we used some other point that was on it, would it still work?
Yeah, that's basically his question. We're just redefining the origin.
Really? I got so confused by my question. That was...
Okay, let's talk about if we have X's and Y's. Okay? So anytime we have multiple points, we're taking the sum of mass times distance over the sum of mass. Does everybody understand that notation? The sum of mass times distance over the sum of mass. Okay? We call this our first moment, but we're also going to notate it, please notate it, m sub y. It's the moment about the y-axis. And we call it the moment about the y-axis because this is all of the mass times distance, where our distance is from the y-axis because we're talking about x distances. And x distances are measuring how far you are from the y-axis. So we call it moment about y. Okay. And this is called the total mass of the system. Okay, boring, we've already talked about that. Okay. Well, now, why am I talking about this being the moment about y? Okay, well, because we're going to have a moment about x now. If I want a center of mass, and we're talking about both x and y coordinates, then to find the y coordinate for our center of mass, we're doing the same thing, except now we have to find the moment about x. So our mass times distance, how far are we away from the x-axis with each of those masses over the total mass? Mm-hmm. Okay, so we're going to find a center of mass. Okay? Now, in order to find the center of mass, we know that to get the x coordinate, we're going to take the moment about y over our mass. For our y coordinate, and I can't write up on the board because I'm in a PowerPoint. For our y coordinate, we would have to take the moment about x divided by m. And I know that feels awkward, but remember we're talking about distances. So the moment about y are all of those x distances from the y-axis. That's why we call it that. For our y coordinate, we're talking about the y distances from the x-axis. So we call it the moment about x. Okay. And this is the problem that we're going to find the center of mass for.
I think I actually understand this one.
Okay.
So far.
So far, so good for Benjamin. You can just put it there and trade it. Okay, so my suggestion, and we're going to do this when we get to the calculus part of it too, but my suggestion would be to find the moment about y, calculate the moment about x, calculate the mass, and then pair up the ones that you need to pair up together. Okay? So, first, let's talk about our moment about y. Our moment about y means we're going to take all of our x distances and multiply them times the mass. So we're going to take 10 grams times the x coordinate of 2, and 7 grams times the x coordinate of 4, and 12 grams times the x coordinate of negative 5. Benjamin, what can I answer for you?
No, it's fine.
Okay.
I think that's fine.
Okay. Some of you may already even be working on the moment about x, but the moment about x, we are going to take all of our y distances and multiply them times the mass. So we have 10 times the y coordinate of negative 1, plus 7 times the y coordinate of 3, and 12 times the y coordinate of 2. And then for our mass, we're going to add the 3 together. 10 plus 7 plus 12 is 29. All right, so now, in order to find the x-coordinate of our centroid, we are going to take, what? What divide which two?
So negative 12 and 29.
Okay, negative 12 over 29 is what we take for our x-coordinate. And 35 over 29 is what we take for our y-coordinate. So the moment about y over mass gives us x. The moment about x over mass gives us y.
2 years of physics and I still forget lowercase I means mass. Good job.
To be fair, you've had a year and 2 months of physics.
Well, physical science though.
This is true. Okay, now, this is where it gets exciting, okay? I've given you problems you could have solved your freshman year of high school, right? Maybe sophomore. We'll say sophomore year of high school. And we could give these problems to like physical science and they'd probably be okay. Don't you think?
I think that's right.
Okay, the calculations aren't...
A little bit overconfident here. Were we supposed to know how to do this already?
No, I'm saying if we taught this to a group of physical science kids, would they understand it? I think so. Okay. Well, now let's talk about what if we had an area. Okay? And you can kind of take a break from writing for right now. We're just going to kind of talk. Okay? So I have uniform density. Okay? I'm going to split this up into infinitely many, infinitely small rectangles. Ring a bell? I mean, that's what we've been doing like all chapter, right? Okay. And the mass of each is considered to be at the geometric center. Okay? Which these are so thin, it's just the center. Okay? The mass of each is the product of density and the area. The mass is density times area. Is that okay with you? Is that a physics concept? I'm not getting any feedback here. Is that a physics concept?
Yes.
That you've talked about? Okay. If we sum the products of the distance and the mass, then we can talk about our moment about x and our moment about y. Okay? So, let's talk about the moments about x and y. let's take any given rectangle. I really bet this
She was asking density times that.
Let's take any given rectangle here. Okay? And we're going to talk about the moment about y. So how far away are any of these given rectangles from the y-axis?
Integral f of x minus
Just
integral.
no integrals. How far away would any given rectangle be to the y-axis?
F of x minus g of x.
Just x. Just x. Any of these rectangles, let me draw them here. Any rectangle, if I talk about its center, is going to be x away.
Oh, from the
I thought you were
y-axis.
saying like.
Okay? Now, we talk about mass times distance, right? So our distance is x. Our mass is area times density. Well, how do we find the area between curves?
Integrals.
F of x minus g of x, right? Top minus bottom. So in order for our moment about y, we have density times area times our distance. And our distance for any of those rectangles would just be x away. Please write this down.
So this is the moment y. So if we were trying to find like x, like
This is going to help us with our x coordinate, yes.
okay. I feel like I could easily see myself getting confused there. So.
What does the P mean again?
That is density. It's rho. Rho is density. It looks like a P, but it's a Greek rho.
Mr.
Row,
Gavin makes us
row.
use that. Yep.
Okay, so now let's talk about the moment about x. And to be fair, I'm fine with you just memorizing this, but I want to explain where the formula is coming from. Okay? Now, if we look at this picture, we now want the moment about x. A moment about x, yes. So I need to know this center of mass at any given rectangle, how far away is it from the y-axis?
Why?
Okay, but we're not going to use y in a dx integral.
Do y and then change the functions to x equals something y.
Okay, how do I find the center of any of these rectangles?
Midpoint formula.
Okay,
Yes.
so basically where I am here plus where I am here divided by 2, right? Okay, well this is just f of x and this is just g of x. Okay, so we're going to have area times density to give us our mass. Here's area times density to give us our mass times how far away we are from the x-axis.
But how does that tell you how far away it is from the x-axis?
Because we take height plus height divided by 2, that gives you the average height of each rectangle.
Oh, okay.
So it's density times midpoint times area.
So this is density times area to give us mass. Times, yeah, the midpoint.
Okay.
Okay. Now some of you might want to rearrange that a little bit, and that's fine. I think our book has it as 1/2 rho times the quantity f of x squared minus g of x squared, because you end up with a difference of squares. If you'd like to do that, that's fine, but I like for you to know where the heck everything comes from.
So how does one of those give you the y, like coordinate of the centroid? Or
Well, this is figuring out the moment about x. That's why we're using like how far away we are from the x-axis. That's giving us our height. So this is going to help us with our y-coordinate. Okay, and we're going to take each of these moments and we're going to divide them by the mass. Okay, density times area. Got it? Okay. This sounds great to do.
I
think you can do it.
Thank you.
Just give us all hundreds. That was like fun.
Okay.
What is this conversation?
Yeah.
So where does the X come from? Or the what's the X
Density,
Yeah,
area, and then
density.
what is the petrol?
The first one.
Oh, yeah.
Oh, okay. So this is density times area to get mass times our x distances from the y-axis, which is why we call it the moment about y. Okay, and as a reminder, we find centroids by taking the moment about y over mass for our x coordinate and the moment about x over mass for our y coordinate. That feels backwards, I know, but the moment about y is how far away we are from the y-axis, which is an x distance. The moment about x is how far we are from the y-axis, x-axis, which is a y distance. Or you can just remember that x goes with y and y goes with x. Right, Isabel?
Yeah. I'm gonna memorize this. I'm gonna feel good, and then I'm gonna screw up. Like the
Now he's
normal
going
ones.
for homecoming queen. Crazy.
Wait, could you go back
Hey,
just a moment
pertinent.
to get this number down? For one person.
Like you just left the sentence.
That's what you wanted?
Yeah.
Sorry.
Quickly get that
Oh
down.
my god, that's
So on the next slide, I'm going to give you a region and we're going to find the center of mass. Now, tomorrow I am going to give you a region, like a physical region.
Wait, is that the who sucks the most?
No. Crap, where'd I put him?
Alright, thank you.
Yep. I'm going to give you a physical region and you're going to calculate the center of mass. You're going to cut out the region and you're going to balance it on your pencil. Where did I put them? I copied these for Mr. Holman. Where did mine go?
It's mean.
Okay, doesn't matter. I'll find it later. Yes.
Okay, so these integrals give us m of x, right? But how do we find just m? Is that right? That's
Okay, this is your region. Ah, here they are.
low text.
Okay, do we have it written down? Okay, so, yeah, sure, why not? Okay, we're going from where to where? We're going from 0 to 4. We have density times x times top function minus bottom function. Was it x squared plus 16? Plus 16?
Yeah.
plus 16.
Like this?
Yes.
Okay. So we have density times area times x. Ooh, and what is this? What should I label this?
That's M.
Moment about
Why?
moment about y.
Ooh, but what about? I don't
So
know.
how do you know density?
No.
We don't.
Don't we
It's
just
gonna
have
a
Be
variable
cool.
at the end.
Be cool.
no
Yeah.
answer midpoint?
I hear what you said, but it's probably really slick. Is it like some
Okay.
like cancel out or something?
Well, what about the
It's gonna
midpoint?
be a variable.
Can you? Yeah. It's gonna be just. You know how we do like 32 times pi. We're just gonna write like 32 times rho if that's our answer, and then just be patient. Okay. Our moment about x is density times area. So that's top minus bottom, times the midpoint for y. So f of x plus g of x over 2. And then our mass is density times area. Once you get this written down, you four are going to math 9 this up here. Just leave density out for now. You two are going to math 9 the moment about x. And you two are going to math 9 the mass.
Yeah, if you change, that's why I shouldn't did the midpoint, so it's not a y. Can you technically do it in a y, but it would just be a lot more work. Like you'd have to change
Yeah,
the equation
yeah,
and
that'd
stuff.
be pretty intense.
What'd you get?
Numbers, what you get?
You tell me, I'll tell you that's what I got.
You haven't even pulled out your calculator.
Aren't those shirts nice? I really like them.
That's a terrible idea.
You wanted to wear it all the time.
Then what did you get?
I fully trust you, Chris.
You keep telling people that.
I got a 1975.
I got 190.
Zane and Matthew, what's our mass?
That's, I got that. That's the right decimal. 256 over there.
256 divided by 3 rho. Moment about y. My group of 4.
192 row.
192 rho. You can't change that to a.
It's
I mean,
a very large
It's all
range.
very, it's one,
14,300.
14,000
336,
Oh, we got this deep.
over what?
15.
Right.
Wait,
So a lot of us have been worried about our row.
They definitely cancel. I feel
If
like
Richard was here, he would have. Thank you. That's what I was going for. Okay. Yes, they're going to cancel out. So our x coordinate is going to be our moment about y over our mass. Boom, our rows cancel. And what are we left with? Numbers? Exactly? 55?
No, I said
25 exactly?
What?
What?
2.25.
What are you saying?
2.25.
Ugh. And our y coordinate is going to be the moment about x divided by our mass. Here again, boom, the rows cancel. And now we have no rows.
So then, technically speaking, do you really even need to write the row in there? Because it's completely kind of useless.
Technically speaking, yes, you need the row.
But they just cancel.
But
it
they do
anyway.
cancel at the end, yes.
So why do they have it in the equation?
Because density is important. As long as it's uniform.
Oh, this is just for uniform.
Yes. What is this?
Yeah, like if it's not you.
What do we get for the y coordinate? 11.2? That's it? Yeah. Well, that's cool. So if we go back to this picture, right? What was the coordinate? 2.25, 11.2. About right here would be our center of mass. If I cut this out on a piece of paper that has uniform density, and I plot that point, it'll balance on our pencil, which is what we're going to do tomorrow. It's going to be so cool. Okay? What questions can I answer for you? Okay. I need you, so we have about 9 minutes left of class. Maybe you can get a couple of those easy ones out of the way, the ones that don't involve calculus, just the linear systems or the XY coordinates. Get a couple of those out of the way, so then your homework is not as much tonight. And then tomorrow we'll go over our homework, we'll go over our quiz, and we'll do our centroid lab. Okay?
Honestly, this wasn't that bad.
So like all these added together, which is 40.
What's going on? Are you spilling candy? Are they good?